All right, so our notes are on indeterminate forms and L'Hopital's rule. Is there anyone who needs the notes from last time? Nice. All righty. So let's just go over what we've been doing. I feel like we've been on these notes for a while, and I mistakenly put some kind of harder examples on this packet, and I do kind of feel bad about that, but it does give us practice using L'Hopital's rule, and when you take the test, you'll be like, oh wow, these ones are not as bad, right? Okay, so we talked about L'Hopital's rule, and L'Hopital's rule works for indeterminate forms, right? Now, I told you, I kind of gave you all the indeterminate forms on Monday. I told you that the most important indeterminate forms are 0 over 0 and infinity over infinity. Those are the two ones that you definitely have to know because, well, you have to use L'Hopital's rule when you see them, okay? Then we started talking about other types of indeterminate forms, which you couldn't directly use L'Hopital's rule on, but you could work with it algebraically or do something weird to make it look like 0 over 0 or infinity or infinity. The types of indeterminate forms that we've looked at so far are 0 times infinity, right? Those are ones that you definitely have to work with in order to solve. We also had infinity minus infinity, right? So that one was another one that we worked with. I told you that I probably wouldn't ask you anything about this one because these are kind of weird and take a long time to do. And then the final ones that we talked about were 0 to the 0th power, infinity to the 0th power, and then the weird one that is kind of hard to conceptualize why it's an indeterminate form. But I told you that if you take more math classes and learn about like ln and the derivation of e, then you'll know that 1 to the infinity power is an indeterminate form. Okay, we kind of yes, it was like, oh, why is that not just 1? You'll learn about it later if you take more math classes. That's what I'll say. All right, so we did a lot of stuff, and we left with this example of something that was a 1 to the infinity power, right? We said that was an indeterminate form, and I actually told you the answer. It wasn't 1. The answer is e to the 4th power, right? And you're like, how does e to the 4th power come out of something that's a 1 to the infinity power? Okay, I'll kind of explain to you why. And let me just show you the steps that we did so far, okay? What I did is I made y equal to everything in the inside of the limit, okay? So I just made this function y, and I said that it was 1 plus sine x to the cosine x, okay? So we're essentially trying to find the limit of y, okay? Then what I did is I took y, which is equal to 1 plus sine x to cotangent of x, okay? And I took the natural log of both sides. So I did ln of the left side, ln of the right side, okay? What they gave us on the left side was the natural log of y. And on the right side, I had ln of everything that I want to find the limit of, okay? What we did then is I used properties of logarithms, which you might remember back from algebra, to take the, the exponent and bring it all the way in front of the log. Okay, I don't know if you remember doing this in calculus readiness, but whenever you have a natural log to an exponent, you take the exponent and bring it up front, okay? So this is the same as cotangent times the natural log of 1 plus sine of x. All right, so now we're here. Let's just do this. I know this looks weird, and I promise it'll make more sense later on. I'm gonna find the limit. And I'm looking as x goes to 0 from the right. And I want to find the limit of not just y, but the natural log of y. Okay, so I want to find the limit as x goes to 0 of the natural log of y. Okay. What is the natural log of y? Not quite. It's what I wrote up there, right? So the natural log of y, let me highlight what I'm doing here. And let me use a bigger highlighter, okay? I want to find the natural log of y. Well, the natural log of y is equal to cotangent x times the natural log of 1 plus sine of x, right? That's what I did there, okay? So instead of writing natural log of y, I'm just going to write what I said it was equal to. Cotangent x times the natural log of 1 plus sine of x. Okay, so I'm just replacing natural log of y with what I found on the right-hand side of the equation. Okay, well, we have a limit. Let's plug in and see what happens. Okay, so let's plug in. I want to find a cotangent of 0 times the natural log of 1 plus sine of 0. All right, we're going from the right here. What is the cotangent of 0 going to, Michael?
1 over 0.
1 over 0 or infinity, good. If you don't see the steps there, remember cotangent is 1 over tangent, okay? Tangent of 0 is 1 over, well, tangent of 0 is 0, so cotangent is definitely going to infinity, okay? Okay, I want to multiply that by the natural log of 1 plus, what's the sine of 0? 0, right? Sine of 0 is just 0. Okay, so this is infinity times the natural log of just 1. And what's the natural log of 1? 0, right? Okay, so this is infinity times 0. Remember, this is an indeterminate form, right? Technically, it's an indeterminate product, right? And we can't just use L'Hopital's rule here because it's not division, right? We need to change this into something that looks like division, okay? Now, I told you that there's 2 tricks to deal with things like this. When we're dealing with just like x or a power of x, we do that weird trick like 1 over x, and it brings it to the denominator. With trig functions, what I like to do is either change things to sine and cosine, which might make things complicated here, or use those reciprocal identities to bring one of the trig functions to the denominator, okay? Is there an easy way to bring this trig function to the denominator?
Yeah, just make it 1 over 10.
Good, right? So I know that cotangent, and let me just write a little note here, cotangent of x is 1 over tangent of x, right? So instead of writing it like this, I'm going to change this formula to look like this. The limit as x goes to 0 from the right of the natural log of 1 plus sine of x all over tangent of x. Okay. Does everyone see how I got from this step to the next? Good. All right, I'm gonna make Michael a little crazy here. I'm gonna plug in again just to see if we can use L'Hopital's rule here. I know Michael's like, oh, I don't want to plug it in, but let's do it. Okay, we want to find the natural log of 1 plus sine of 0 over tangent of 0. Okay, I'm not going to go through this because we actually found those values on the right. The natural log of 1 plus sine is, I think it's, gosh, actually, that's going to be 0, right? And tangent of 0 is 0. So this is a 0 over 0 type limit. We can use L'Hopital's rule. It's always good practice to check if we can use it or not. Okay, so next step, using L'Hopital's rule. L'Hopital's rule says take the derivative of the top and divide it by the derivative of the bottom. And looking at this, it looks like we might have to do a little bit of work to find the derivatives, right? Why don't we find the derivatives first and then use L'Hopital's rule? Okay, so let me use a different color here. Okay, let's do the derivative of the top. Okay, so I want to find the derivative of the natural log of 1 plus sine of x. Okay, what rule am I going to have to use for this? Chain rule, good. What's my inside function?
1 plus sine x.
1 plus sine of x. What's my outside?
Natural log.
Yeah, natural log of something, right? I know some of you use u, but I like using the box. Okay. All right, to use the chain rule, we have to do the derivative of the outside first. So what's the derivative of the natural log of something?
1 over 1 plus.
Yeah, 1 over that something or the inside. Okay. And then what's the derivative of 1 plus sine x? Cosine x. Okay. Once I'm done doing the chain rule, you can just write the inside back in the box. So this is 1 over 1 plus sine of x. Okay, so the derivative of the natural log of 1 plus sine x is cosine x over 1 plus sine of x. All right. Now the derivative of the bottom is just easy, right? So I'm not going to write that out by itself. Let's continue using L'Hopital's rule. Okay, so L'Hopital's, we're continuing the limit of the natural log of y. Okay, so I want to find the limit as x goes to 0 plus. The derivative up top is literally what we found here. So I'm going to write cosine of x over 1 plus sine of x. What's the derivative of tangent of x?
Secant squared.
Secant squared, good. That's a good idea. I'm actually going to leave it like this just because that's kind of what the textbook did, but it is easy to do that. Yeah, I agree with that. All right. Now that we're here, why don't we just simplify things a little bit? You know what?
You could just make it 1 over.
Yeah, let's do it. I didn't do that in my notes, but let's do it. I think that's a good idea. All right. Let's rewrite this as a fraction over a fraction. So cosine of x over 1 plus sine of x. And I think what everyone's telling me to do is to change secant squared into 1 over cosine squared, right? Is that what everyone kind of wants me to do? Good. All right, we can do keep, change, flip. So this is the limit as x goes to 0 plus of cosine of x over 1 plus sine of x, keeping that the same, changing the division into multiplication, and flipping over 1 over cosine squared x to be cosine squared x all over 1. And I know you can't see that, so let me zoom in here. Okay, so we're here. Looks like I can combine the cosines. So instead of cosine times cosine squared, this can be cosine cubed, right? So let's make this the limit as x goes to 0 plus of cosine cubed of x over 1 plus sine of x. Okay. Well, now we're here. We have the limit of a fraction. Let's just plug in and see what happens. Okay. So we're going to plug in here. We want to find the cosine cubed of 0 over 1 plus sine of 0. All right. Now, for some reason, oh, I changed the question. That's why this looks weird. All right. What's the cosine of 0?
1.
1, good. What's 1 plus sine of 0?
1.
1. So this limit is equal to 1. All right. Well, I told you that the answer to this question, and I did the wrong question here. I told you it was e to the 4th. The answer is e, okay? But we got 1 as our limit, okay? So why is 1 not our answer? Actually, it's not an indeterminate form.
No, it's not. I just don't have it.
What is 1? What is this the answer to? What is this limit?
To L and Y.
Good. This is the limit. So this is the limit as x goes to 0 plus of the natural log of y. Is that what we want to find the limit of? No, we want to find the limit of y, right? I want to know. So the question is asking me what the limit as x goes to 0 plus of just y, right? Y is equal to the thing I want to find the limit of. I found the limit of the natural log of y. I want to know the limit of y. Any ideas on how to do that? Okay, e, good. There's an e in here. Not multiply. Close though. No, divide's a little bit further. The exponent. Okay, so I think what you guys are saying is e to the natural log of y. What is that? Y, right? Because the e and the natural log cancel each other out. So isn't saying the limit as x goes to 0 of y the same thing as saying the limit as x goes to 0 of e to the natural log of y? Good. Okay, this is the trick that always happens with these sort of questions. Okay, we go from here to here. Just rewrite y as this. I know it looks weird. Okay. What is the natural log of y going to? That's going to 1 because of our answer here, right? Okay, so this is literally e to the 1. Okay, e to the 1 is just e. That's my final answer. Okay, that was a lot of work, wasn't it? I think this was a lot of work, but whenever you see L'Hopital's rule that has like an exponent in it, and we're doing an indeterminate exponent, okay? The question always ends up like this, okay? I know it sounds weird, but it's kind of like a system, okay? And I kind of wrote out this system for you in the next page, okay? Whenever you see 0 to the 0, infinity to the 0, or 1 to the infinity, what I'm gonna do is I'm gonna talk about this in a weird way, okay? Let's say I wanna find the limit of some function f to some function g, okay? In the last example, it looks like f was the 1 plus sine of x, right? And it looked like g was our cotangent of x. Okay, so that's kind of what we were doing, okay? The first thing you're going to do is let y equal to everything that you're trying to find the limit of. So we said that y was equal to 1 plus sine of x to the cotangent of x. Step 2, you're going to use properties of log. So you're going to take the ln of y and you're going to take the ln of the right side, and it's going to look like this: g of x, or cotangent of x, times the natural log of f of x, which is 1 plus sine of x, right? That's what we did, okay? So you're just going to take the natural log of both sides, okay? 3, you're going to do L'Hopital's rule, so you're going to turn the multiplication into some sort of quotient, turn it into a fraction. 4, you're going to find the limit of the natural log of y, which is what we did. That's what we got. We got 1 there, okay? And then the 5th thing we're going to do is we're literally just going to do e to whatever we did, okay? So the natural log, the limit of y is the same as the limit of e to the natural log of y, okay? I know that's a lot. Let's do one more example, and then I'll let you on your own, okay? I know this is a lot. I know it's a lot, but we'll get through it, I promise. Okay. Example number 15. We want to do the limit as x goes to 0 of 1 minus x to the power of 1 over x. Okay. Remember, first thing we do is plug it, right? We want to see if this is an indeterminate form truly. Okay. Well, we got to do 1 minus 0 to the 1 over 0. Okay. 1 minus 0 is 1. What's 1 over 0? Infinity. Good. This is 1 to the infinity. I know it's very tempting to be like, this is definitely 1. I will tell you the answer is 1 over e. Okay, so it's not 1. Okay, so this is an indeterminate form. All right. So let's just take a look at the steps. Okay, step 1 says let y equal to everything that we're finding the limit of. So let me just write this out in our steps. Step 1, let y equal 1 minus x to 1 over x, right? Pretty easy. All right, looks like we can move on to step number 2. Step 2 says use properties of log to write the natural log of y equal to something, okay? So what this step is telling me to do is to take the natural log of both sides, right? So I'm going to do the natural log of y and the natural log of the other thing, the natural log of 1 plus x to the 1 over x. Maybe I should use brackets here. Is it minus? Yep, thanks. 1 minus x saved me some trouble there to the 1 over x. Okay. We're still on step 2. We have to use properties of logs. So on the left, I have ln of y. What do I have on the right-hand side?
1 minus x times 1 over x.
Perfect. ln of 1 minus x times 1 over x. We're just taking the fraction and we're like moving it over, right? So we're moving it up front. Okay, so that's what I'm left with right now. Cool. All right, so that's the end of step 2, right? All we're doing is rewriting this, okay? Step 3, we basically want to find the limit as we're going to whatever we're going to of ln of y, right? So I want to find the limit of ln of y. And using what I just wrote in step 2, I know that ln of y is 1 over x times the natural log of 1 minus x. Okay. Now, remember, we have to plug in, so let's do that. Okay, we have 1 over 0 times the natural log of 1 minus 0. Okay, what is 1 over 0 going to? Infinity. What's the natural log of 1? 0, right? So this is definitely an indeterminate product. I'm sure you can kind of already see how to do this. How do I rewrite this as a fraction?
ln 1 minus x over x.
Yeah, right. ln 1 minus x over x. That's pretty easy, right? It just goes to the denominator. Okay. All right. Let's see. So that's basically step 3. Step 4 is just finishing out this limit, right? So step 4. Okay. Now it is good practice to plug in before you find the limit. I'm going to be lazy and not plug in, but let me just tell you, if you plug in, you're going to get 0 over 0. Okay, so we can use L'Hopital's rule here. Okay. All right. When we use L'Hopital's rule, looks like we're going to have to find the derivative of that top function, which does look a little bit weird. Let's do that on the side here. So a derivative of the top, or which is ln of 1 minus x. What rule are we using here? Chain rule, right? So got to have an inside, got to have the outside. Okay, what's my inside function? Good, 1 minus x. And I'm pretty sure it's clear that the outside is pretty much always going to be ln in these types of questions, right? All right, got to do the derivative of the outside, which we said before was 1 over box. Multiply by the derivative of the inside. What's the derivative of 1 minus x? Ooh, -1. Good. Gotta pay attention to that sign there. And then we can stick the inside back in the box. So the derivative is -1 over 1 minus x, at least of the top. All right, now let's use L'Hopital's rule. Okay, so we're doing the limit as x goes to 0. The derivative of the top is -1 over 1 minus x. What's the derivative of the bottom? 1. Good. All right, that makes things really easy for us, right? Because anything over 1 is just itself. So I'm looking for the limit as x goes to 0 of -1 over 1 minus x. All right. Once we're here, we can definitely plug in and figure out what we have to do. So plugging in, I'm going to plug in -1 over 1 minus 0. And that looks like it's -1 over 1 or just -1. Okay, so I found my limit. Is that my final answer? No, right? This is the limit as x goes to 0 of the natural log of y, right? Now let's go to step number 5. Okay, step 5 says limit as x goes to a of y is the same thing as e to like the natural log of y. So you can rewrite this as the limit. It's probably good practice to do that. But really all you have to do is take e and take it to the power that you just found, right? So since we found -1, just stick that there, okay? And that's the same thing as 1 over e. That's my final answer. All right. Any questions on this example? Does doing this in steps make it a little bit easier? I think seeing the step-by-step makes it a little bit, I don't know, breaks up the steps into something that you can memorize at least. I think this will help you. All right, why don't you flip to the back page? We have a very similar example. Might want to do more manipulation of things algebraically, but I'm going to give you a few moments to try example number 16, and then we'll come back in a little bit. I think it's a good idea to just go through this step by step since there's so many different steps here. I want to make sure that everyone's on the same page. Let's go through this really slowly. So we go through each of these, okay? When I walked around, I think everyone was okay with step one. Okay, so step one was just letting y equal what we're trying to find the limit of, right? We want to let y equal x to the x. Are we good with that? Good. Okay, oh, I forgot to plug in, right? Plugging in is the first step. When you plug in 0, you get 0 to the 0, which is an indeterminate form. We're good with that. Okay. So step one, pretty easy. Just let y equal to that. I saw everyone start step 2, which is taking the natural log of both sides. So we have the natural log of y equaling the natural log of x to the x. I think everyone was good with that too. Okay. Now, I think I saw most people do this. In step 2, you're going to take the exponent and you're going to bring it up to the front of the log. Okay. So the third step here is to take the exponent and bring it up front. So we have x ln of x. Okay. Any questions so far? Good. All right. Once we're here, we're done step 2. Let's go to step 3 where we're trying to find the limit. Okay. So step 3, we definitely want to find the limit as x goes to 0. And because we can't really find the limit of our beginning function, let's find the limit of the natural log of y. Okay. Now, another way to say natural log of y is to just replace natural log of y with, well, the other side of the equation, right? So instead of writing natural log of y, I'm going to write x times the natural log of x. Okay. Are we good so far? Good. Once we're here, we can plug in and see if we have an indeterminate form. Okay. Plugging in, we have 0 for x, natural log of 0. What's the natural log of 0? What's that going to?
Negative infinity.
Good, negative infinity. So this is definitely an indeterminate form of 0 times negative infinity. All right. I think we're on, is this step, I think we're still on step 3. I'm going to pay attention to the steps here. Yeah, now we're still on step 3. We want to make this equal to a fraction, right? We want to change this multiplication into something that looks like a fraction, okay? Does anyone remember the trick that we used for this? Sam?
Turn x into 1 over x.
Perfect.
1 over x. And then 1.
Good. Whenever we have multiplication going on, and especially when there's like x or a power of x or something like next to the ln of x, what we're going to do is we're going to take this x here and we're going to change it into a fraction over itself. Okay, and if that doesn't make sense, here's what we're going to do. I'm going to keep natural log in the numerator, and instead of writing x, I'm going to put it in the denominator and write it as 1 over x. Does everyone see how I got there? Okay, so this is kind of like a very common math trick with L'Hopital's rule. Okay, so let me actually label it. Okay, common math trick. And usually when you have something that looks like this is kind of just going to be something that you do a lot with L'Hopital's rule. Okay, if you do a couple of the practice questions that I put on the extra credit, you'll see that this happens a lot. Okay. All right. So you're going to plug in again and see that you have another indeterminate form. But step 4 tells us that we have to use L'Hopital's rule, right? So step 4 is we have to go ahead and use L'Hopital's rule. Okay. What's the derivative of ln of x? 1 over x. Good. So the derivative natural log of x is 1 over x. What's the derivative of 1 over x?
Negative 1 over x squared.
Good. Negative 1 over x squared. Now, if you don't see how that happened, let me just kind of write on the side how that happened. I want to find the derivative of this. What's another way of writing 1 over x?
X to the power of n.
X to the power of -1. Good. So if I want to find the derivative, okay, you're going to take the power, put it up front, and then subtract the power by 1. Okay, so this is negative x to the -2, which is -1 over x squared. Okay, so that's how we got the denominator there. Okay. Once we're here, looks like we can keep, change, and flip, right? Remember, keep the top the same. So I'm going to keep the 1 over x the same. Okay, let me go do this. Change the division sign to multiplication, and then flip the bottom fraction around. So negative x squared over 1. Okay, so the bottom one ended up getting flipped. Okay. Once we're here, we have the limit as x goes to 0 from the right of negative x squared over x. Okay, how can we clean that up? Yeah, I would simplify before we do L'Hopital's. You can do L'Hopital's rule again here, but to kind of avoid it, you can cancel out the x's, right? There's an x squared up top and an x on the bottom. We can cancel those out. And this really is the limit as x goes to 0 from the right of negative x. Okay, doing L'Hopital's rule would work, but I'm going to save myself a few steps there. All right. What's the limit as we go to 0 of negative x? 0. Perfect. Okay. Is 0 my final answer? No, right? We still have step 5 to do, which is essentially saying the limit as of ln of y is the limit of e to the ln of y. But really all we have to do is take e and stick what we got from step 4 in the exponent, right? What's e to the 0 power? 1. Good. So our final answer is really 1. All right. Any questions on example number 16? Okay, now looking at all the examples that we did so far, we did example 14, which was a lot. I'm going to say for L'Hopital's rule, I'm going to keep it simple. Okay, if anything, I might have like a negative exponent, but I'm not going to throw you something with like trig functions for the test. Okay, so I know we did a lot with trig in this class, but I'll give you a Thanksgiving treat. No trig for L'Hopital's rule in the exam. Does that sound good? All right. Well, I don't really have anything else for you. So I guess how about this? Next class, we'll do review for the exam. On Friday, we'll do the exam, and then Monday we'll have class either on Zoom or whatever.